Here's how we've written the concrete grammar of the language that we're implementing so far, where we describe the syntax in terms of S expressions, which reflects the way that we quote the concrete syntax to get a racket value. In many contexts, I'm going to start writing the grammar this way instead. This is called Backus-Naur form, or BNF, and the things in angle brackets here are called metavariables, and this expr metavariable stands for the set of all things that fit into the grammar, where we have 5 cases. It's the same information as we have in the racket comment above, where we have some built-in metavariables like number and symbol. And then if something's not in angle brackets, it means a literal, so a literal curly brace plus, and then 2 exprs, and so on. If I take this way of writing things, again, it has the same information also as our defined type forms, which has 5 cases and, for example, says the application form has a symbol and an expression. I'm going to take this way of writing things, though, this BNF form, to start talking about a new syntactic form, a new addition to our language, and this one is called let, and it's a local binding form. And the syntax is literally open curly brace, literally the word let, curly brace, square bracket, some symbol, some expression, and some other expression. And it may seem that we have an overabundance of parentheses and brackets here, but I'm using them to stick with something that also matches racket as it happens. The intent of this form is to locally bind this identifier to the result of evaluating this expression. So the idea is that you evaluate +1, 2 to get 3 first, and then wherever you see x in the body of the let, that is this expression here in the grammar, whenever we see x, it gets replaced by 3, and that's how we get 6 out. The let form is in the grammar of expressions, which means we can use it wherever expression appears in the grammar. In particular, we could use it as the first argument of a plus. So here I have that same let expression as before, which evaluates to 6, and so 6 plus 1 is 7. I could also make both of the arguments to plus let forms. And in this case, we have 2 let forms that both bind x, or locally define x, but these are different x's. In particular, this x only applies to the body of the let, this region, and this other x only applies to this other body. So in this case, x evaluates to 3, and we add it up to get 6. In this case, x evaluates to 1, and we add it up to get 2, and then the 2 and the 6 are combined together to get 8. It wouldn't matter if I change these x's to y's as long as I change them all consistently, because now I'm binding y, and these y's refer to that y. Another place that we could put a let expression is in the body of a let, since that's an expression form, so that we could end up with this kind of expression, where I'm binding x to 3, and then I'm binding x to 1. So what should this x here mean? The rule I have in mind is that the closest x is the one that we refer to. So both of these x's refer to the one that's defined here. If I change this one to y, this inner one to y, now the closest x is the one out here, and so both of these x's are 3 to get 6. What if I use an x over here? The intent is that this x becomes available only in the body, so at this point the closest x is this one. So you have let, you have an identifier that starts being used in the body. Meanwhile, you have an expression that sees bindings that are outside of this let. So that's why this x means 3, so that we get a 1, so that we add 1 plus 1 to get 2. As usual, we can take this concrete grammar and reflect it into what I sometimes call abstract syntax, or the expr defined type, where we've just added a new case, a new variant, letc, which has a symbol for the name that we're locally defining. The right-hand side, that's what RHS stands for. It's right hand because it's to the right of the symbol. Provides the new value for that symbol, and then the body, which is also an expression. So we've got a symbol and 2 expressions.